In this video, we're going to go through the process of creating a resistor in Magic and extracting it and looking at the corresponding schematic elements in Xschem. So in particular, the resistor we're going to be doing, or we're looking at, is the so-called P- poly precision resistors. So these devices have a sheet resistance of about 2,000 ohms per square nominally, which is quite nice. Doesn't take quite as many squares to get up to 100 kilo ohms at 2,000 ohms per square as it would, say, at 50 ohms per square, which might be the typical sheet resistance of regular polysilicon. So this is a really nice option that the process has for making good resistors. You'll notice that you have here currents up to 500 microamps per micron of width is the limit of current flow. So you should be aware of that, and that will guide you to some extent into how wide you should make your resistors. And you can see here the preferred maximum would be actually no more than 100 microamps per micron width. So that's something to keep in mind. Okay, so that's the device we're talking about. The model is going to be Sky130 FD PR Res X high PO. Okay, the generic one doesn't have one of these actual size sort of suffixes on it. 5P73 would be the 5.73 micron width option. OP35 would be the 0.35 micron width option. There's also a variable W over L option. That's the one that we're going to be going with here. And so that would be this one right here. This is a 3-terminal device, so it extracts both as sort of that both ends of the resistor extract as 2 terminals, and then there's a body terminal, which would be the substrate underneath the resistor. So bear that in mind when you are thinking about these things. Let's see. Okay, so the first thing to do is to pull up a terminal, and we will cd documents restut, and let's pull up Magic. First thing we're going to do is set up the grid. Okay, so I think we're going to go for a 20K resistor nominal, just to show you what that would look like. So we're going to use a 0.35 micron width, which is the minimum width allowed by design rules. So that means that we want 10 squares. Okay, so 20K ohms at 2K ohms per square means we need 10 squares, which means we need a box that is 0.35 by 3.5. All right, there's 0.35. By almost there. Can't win. There we go. 0.35 by 3.5. So that's the size of the actual resistor. And the layer we want to paint in is called X poly res. And so we can just paint X poly. X poly res. There we go. And then we need to put a contact up at the top and the bottom. And it turns out that those need to be, see, 2.2 microns tall. X poly contact. So that would be this one right here, X poly contact. And just repeat that command. And that's actually the resistor. So let's put some labels in here. Let's label top, north in local interconnect. And that's putting a label bot in local interconnect. And for fun, let's put a P substrate contact over here. Let's see. And let's see, we'll put local interconnect here. And we'll call this ground. So we're going to do extract all, next to spice, and we're going to turn scale off. And let's go out here, grab another terminal. So you can see that this is extracted as a 3-terminal element with this model, Sky130 FD PR res x high PO, with a width and a length parameter. And so here the width is 350,000 micro, which is 0.35 microns, and the length is 3.5 times 10 to the 6 micro, which is 3.5 microns. Okay, so now you'll note that the third terminal was the substrate. We labeled the substrate contact with ground, and that was what we got as our third terminal there. So now if we wanted to fire up Xschem, we can insert a symbol, and this is again going to be in the Xschem Sky130 directory under the Skywater directory, under Sky130 FD PR. And we're interested in Xschem. And if we wanted to here, we could put in the width is 0.35 and the length is 3.5. And we could label lab pin. Whoops. And we could call this top. But, and then we could grab the ground symbol, let's say. So we could save this as resistor 20K Xschem.sch. And now if we netlist this and we say we edit the netlist, I have XR1 bot top ground. Not quite sure why it all came out in caps. Let's just try running Xschem again. And let's try netlisting again. There we go, that's better. I must have had some funny keystroke that I made the caps lock enabled there or something. So here we have our 0.35 and 3.5 with bot top and ground. And so if we save this as, and then go to document, res2, and save that. We could, oh, I don't know, make a new tab here, and we could try LVS resistor 20K.spice resistor Xschem 20K, or sorry, resistor 20K Xschem spice. Circuits match with one symmetry, resolving automorphisms by property value, by pin name. Netlists match uniquely. Circuits match correctly. How about that? Hooray! There you have it. So there's the P- precision poly resistor. If we wanted to make a larger resistor, we could of course make a higher aspect ratio here. At some point we might want to actually make several of these strips in parallel, breaking it up into subunits, and then we could just connect straight across here in local interconnect, kind of snaking back and forth to fold it up into something more of a square-ish footprint. So for instance, if we wanted to make a 100K resistor, we could make this 5 times longer, but this is really long and skinny. And so it might be better to break it up into 5 20K subunits and then just connect those together in series with each other by just kind of, like I said, snaking it back and forth by making little horizontal local interconnects here. And I might probably go through the whole width of the thing. So if I wanted to, for instance, I've got some crazy thing going down here because I hit the colon key. What I might do is I might grab this, so you can actually see here we got a design rule violation. So you actually have to have these a fair bit apart. They have to be, these resistors have to be at least 44 grid units, or 1.25 microns on the 50 nanometer grid spacing apart. And so we need to move them a little bit further apart, so we can move east 1. That looks good. Oh. Looks like we're the woods there. And if I wanted to connect these two strips together in series, I would probably just do something like paint local interconnect there, and then if I want to do another one, I would make another strip here, and I would just continue kind of zigzagging back and forth like that. Sometimes people put a guard ring of substrate contact around the whole thing. I don't think that's really super necessary in most cases, unless you've got some digital stuff banging around nearby. Anyway, that's how I would do resistors. There are other options for resistors. There's a more heavily doped P resistor, poly resistor, which has lower sheet resistance, but not crazy low. That might be more appropriate if you're interested in making something kind of in the 1K range or a few hundred ohms range, rather than the tens of kilo ohms to hundreds of kilo ohms range. But I figured the hundreds of kilo ohms, tens to hundreds of kilo ohms is probably what we're more interested in for our purposes, and so I decided I would go over the P- precision poly resistors. Anyway, hopefully that's helpful, and we'll see you next time. Thanks for watching.